Namaskar. I'm Harpreet Kaur and I welcome you all to our 5-day, 5-hour online training program on device and network security. You are watching us live on PM eVidya channels 6 to 12 and also on our YouTube handle NCERT Official. This training program is brought to you by Central Institute of Educational Technology, that is CIET NCERT, in collaboration with C-DAC ISEA Hyderabad. Today we are in day 3 of the training session and the topic that we have taken up is mobile and app security. If you wish to participate in the session, please feel free to contact us. Our phone number is 8800440559. Our email ID is training.helpdesk@ciet.nic.in, and on our YouTube handle NCERT Official, you can send us your questions, suggestions and your feedback. I request all of you to kindly not mark your attendance and ask relevant questions. I would also like to apprise everybody out there that it's a training program, so there is going to be an assessment on the last day of the training session, that is on day 5, Friday. So if you wish to participate in the session, we request you to kindly watch all our sessions very carefully, and you can log on to CIET website for all the guidelines and instructions. If you score more than 70%, you will be granted a certificate that you can download from DIKSHA portal. And lastly, for sharing your feedback about this entire training program, you can always write an email to us. And now it's time for me to introduce you all to our expert for the session. So please join me in welcoming Mr. Venkat R. Kodimela. Sir is project manager from C-DAC Hyderabad, Telangana. Sir, namaskar and very warm welcome to the session.
Yeah, thank you for inviting me and giving me the opportunity.
Well, pleasure is all ours, sir. And before you delve deep into the topic, I request you to kindly share with us the brief of all the main points that you will be covering in the session today.
Yeah, thank you, madam, and good afternoon to all. And as part of this session, we would be covering like the major aspects regarding the mobile app and the security implications that one should be taking care to improve the security posture of the application. So, what are the steps or what are the methods that one should follow to make the application secure, and what are the practices that the developer or to follow to make the security of the application to improve. So those aspects will be discussed in detail in this presentation, in this session.
Right, sir. And all the viewers who are watching us right now, you can ask your questions. Of course, you can send them in the live chat box and we will take them up by the end of the session, by the end of the presentation to be precise. Now, sir, I request you to kindly go ahead with your presentation, and it's all yours now.
Yeah, thank you, madam. So as part of this session, let me just take you through the agenda. So we will be covering the security analysis of the mobile application. So what are the aspects or what are all analysis methods that one can follow to perform the analysis of the mobile application? So we have the OWASP, MAS-VS and MAS-TG. These are the guidelines that are provided by OWASP, which is Open Web Application Security Project. So we also have we'll try to continue with the advanced security analysis of Android apps. So there are few aspects that one can follow to go into a deeper analysis phase to see what are the security vulnerabilities that are existing in the given app. So we also try to cover the reverse engineering of Android APKs. So here we will try to touch upon the method or the procedure that one can follow to reverse engineer to see how this source code of the given mobile application, which is Android application, can be analyzed and what are all aspects that one can look for to see whether the source code is having any vulnerable information is not, or not. So later we will try to cover the tools which could be used for reverse engineering, and lastly, what are the aspects one can protect, like one can protect from reverse engineering part, because if a given APK, then APK the developer should able to protect it from the reverse engineering as well. So what are the aspects that developer can follow to protect his own or her own app APK from reverse engineering attempts? So, so firstly we'll look into security analysis. So what is security analysis? So as we see, there is a rampant proliferation of mobile apps through app stores and play stores. So you see like millions of apps are available, and there are there is no proper check whether what that app is going to perform, and what aspects or what device details or what your personal information will try to seek from you. So those aspects we have to we are not sure. So for that we need to perform security analysis. So as we know, the mobile applications are would be installed on the mobile devices which contains the sensitive information of the users. So that in the user information, if it is in the in the wrong hands, then in or any adversaries, then what implications that could cause on your identity. So we all understand, and there are the attack vectors are growing in such a way, like, so there are sophistications are bringing into the attack vectors, and with which the devices and the mobile apps are getting vulnerable. So for these reasons, we have to go for security analysis of the mobile app which we are going to install on our device. So why security analysis matters? So as I told, it helps us to prevent any data breaches, because we store a lot of data on our devices, but due to some app which is not analyzed securely, which is not secure, then that could steal the data from our device, and it may use for any adversaries, like in any adversary purposes. So for that we have to do security analysis. So to be compliant with industry regulations, there are a lot of industry regulations like HIPAA is there, GDPR is there, DPDP is there. So we have to comply. The app which is going to install on your device should comply with these standards or regulations, so that that will give you some shield in protecting your personal data. So to build user trust, like if the app is not secure, and it is in the public domain, and most of the users put comments like about that app as such it is insecure, then there is a breach of trust, and also the confidence in that app will be reduced by the user community. So to upkeep the confidence of the users, so security analysis is matters like, and also the business reputation will also take a bad hit if the application like if the users find that application having more vulnerabilities, and it is not storing the personal information or trying to steal the personal information, then the reputation of that application will also have a will also take a bad hit. So to considering these aspects, so one given an app, the analysis on the security aspects is very important, and it is not only important for the user but also for the business institution from which that app is released. So what are the aspects that we try to look into as part of security analysis? So as I told, it could be data storage. So whatever the data that is stored on the device, so what procedure that it is that the app is following or the developer has implemented. So like if the data is stored, then there are certain encryption methods that should be adopted by the developer for storing the sensitive information. So what communication aspects that the developer has implemented in the application? Like there are HTTPS and TLS protocols, so which are using untrusted certificates. So if it is untrusted certificate, then the adversary could easily intercept the traffic and steal the personal information of the user. So the app maybe they may not be having the multi-factor authentication, so which also gives the attacker a chance to steal your one-factor authentication like the password or username, and also by which the attacker may try to log into your application, mimicking that he is the original user as such. So there could be third-party libraries which already having some vulnerabilities which are reported, so which are implemented as part of the source code or in the application. So this could also take a which will help the attackers to uh, perform certain attack vectors on your application on your device. So and there would be reverse engineering prevention. So there are certain procedures that developer can follow after completing the developing part, so that the code cannot be easily readable by any attacker or anyone who tries to reverse engineering the application, the APK. So there are certain procedure like code obfuscation is one procedure, one method that developer can follow, and there are certain tools which are RASP tools, which are called runtime application self protection tool. So which is an SDK, a software development kit, which will be imported into the source code, but it will try to see that while after reverse engineering the APK, then the source code will not be in the readable format. So, what could be the challenges that one can see while doing the mobile application security? So, there are platform-specific vulnerabilities because there are a lot of fragmentation of devices that are there in the market. So, the versions are fragmented. For Android, there are many OEMs, and for each OEM, there could be a lot of models that they are releasing, and each model may have the its own OS. So, so this kind of fragmentation will give more difficulties while performing the security analysis. So there could be developers who are not adhering to securing secure coding practices. Like there are conventional methods, but the secure coding practices to be followed, so that uh, that will if the developer follows the secure coding practices, then that may give very tough time for the attackers to reverse engineer and try to understand the source code. So as we see, there are a lot of threats that are evolving or emerging every day, and for that, the attackers will try to mimic or try to claim that the application was developed by them, and they will try to release in the market. So for that, we have to make sure that the developer is following certain coding practices with which certain practices can be avoided. And as I said earlier, there are compliance needs. So we have to adhere to GDPR, CCP, and other industry standards like OWASP, MASPS. So with which we can improve the trust in users about our application. So coming to static analysis techniques, so there are security analysis techniques. So basically, we have two major techniques as part of security analysis. One is static analysis, so which is analyzing the application without executing the application, without during like without executing the application. So we install the application and we launch the application. So the launch of the application means we are trying to run the application. Here we will not install the application, but we will take the APK and go to our desktop or the PC, and there we will try to reverse engineering the source code and look into the source code for any vulnerable data that is present in the source code. So this is as part of static analysis. The tools that are used are MobSF and reverse engineering tools, which are JADEX, GUI, and APK tools. So we'll have more like in-depth coverage in subsequent slides. And the target that we will look into as part of static analysis would be the hard-coded credentials, misuse of permissions, or insecure APIs. And coming to dynamic analysis, as I said, so analyzing the application during runtime. So we will launch the application and see what is the behavior of the application, how the data is getting stored onto the device, how the communication between the client and the server is happening. So these all aspects that will be covered as part of dynamic analysis. The tools that we will use are the bug suit for intercepting the traffic, the Frida, which is for dynamic instrumentation tool, or the Drozer. So the focus would be to check the runtime behavior, the insecure communication between the client and server, the root detection bypass, and the insecure data storage. So we will try to get into static analysis to understand what it is all about. So as I said, static analysis can be called as static application security testing, which is a critical process of security analysis and which is performed early in the software development lifecycle. So it can be called as shift left activity. So it is able to identify vulnerabilities, bugs, or any coding issues before the application is actually built and released into the App Store. So the static analysis or the SAST can be performed manually or using any automated tools. So as I told, Android application is APK, which can be decompiled to gain access to the source code, bytecode for analysis. So we are having certain tools which can be used for decompiling. So how it will be helpful is, so it will be helpful to detect hard-coded credentials, so any insecure APIs that are implemented in the source code, or any weak cryptographic algorithms which are implemented in the source code. So it will also help to analyze critical or suspicious areas manually, so focusing on application logic and sensitive operations. So these are all these static application benefits that one could get by performing the static analysis. So these are the tools for performing the static analysis, which are MobSF, which is mobile security framework, which performs static analysis, and the other one is JADEX GUI, which is used to decompile the APK into the readable source code. We have APK tool for this is also used for reverse engineering, and there is another tool Quark, so Quick Android Review Kit security tool, which tool specifically designed for static analysis of Android applications, and there is one more tool, Vidra. So this is also used for reverse engineering, but these all tools are used for specific purpose, and we have to analyze. We have to first understand the requirements and accordingly, so choose the tool for the analysis. So what are the vulnerabilities that one could find as part of static analysis? Like security flaws such as insecure data handling, hard-coded secrets, improper input validation, old coding conventions like poor coding practices, performance issues like inefficient algorithms which are implemented, and standards violations like non-adherence to coding guidelines or regulatory standards. So what are the key benefits? So the key benefits could be early detection of issues reduces remediation cost. So the bug which is detected as part of in the development phase may reduce the cost to a like to more than half of the cost, and that can be fixed easily by the developer. So it improves the code quality and adherence to coding standards. It also supports secure software development by identifying vulnerabilities early. It also tries to enhance the security towards detecting critical vulnerabilities. So as I told, we could find in the source code there could be hard-coded credentials which are left to the developer. There could be SQL injection vulnerabilities like what are the program constructs that are used by the developer for SQL for accessing the SQL databases in the source code. There could be cross-site script in this. So what are the how the developer has programmed, and does he implement any coding practices as such or not? So there could be insecure API calls. So these are all key benefits that one could get after doing the static analysis. So now coming to dynamic analysis, this is basically analyzing the application during runtime to identify the security vulnerabilities, any performance bottlenecks, or any functional correctness. So the useful this is useful in detecting the user interactions or execution environments or any external systems with which the application is trying to communicate. So it simulates the real world conditions to detect security issues. So the dynamic analysis will try to create or simulate and the real world conditions in order to detect security issues or vulnerabilities and misconfigurations that are left by the developer. So it involves testing the functional aspects of an application to ensure that all features behave as expected under normal, edge or adverse conditions. So we will try to navigate all through the control flows of the application and try to see in any control flow any of the issues that could create any vulnerability or not. So this is the dynamic analysis. So the focus areas could be so monitoring runtime behavior like storage of personal data. So once you log in into the application, then the login data will be stored somewhere on the device. So we have to see whether that storage is properly done, whether the storage is in plain text format or a plain text form, or is the developer adopted some encryption method to before storing the data on the device. So any runtime permissions or system interactions like it could be with the server, like how the system is getting interacted. So intercepting or analyzing network traffic, as I told. So there could be some while communicating with the server, the attackers may try to intercept, but the developer should adapt certain encryption standards while communicating the data with the server. So testing how the app responds to different inputs. So there are a lot of input fields that could be implemented as part of the app's functionality. So how the input is being taken by the application. So any locking mechanism or any implemented threshold that are set by the developer, because if the attempts failed attempts, if it crosses three attempts, then the application should be the account should be closed. So that those aspects have been properly taken care by the developer or not. So these all aspects we have to check as part of can be checked as part of dynamic analysis. So the benefits could be provides actionable insights into the runtime behavior of the mobile applications. Like as I told, it could identify the runtime vulnerabilities. It could improve the security posture. It provides deeper insights into the network security. It validates the secure data storage. It detects the exploitable application logic. So it confirms anti-tampering or root or jailbreak detection. Rooting is something the for Android it could it is applicable for Android routing the device. So the routing device is something like we are taking the security aspect which are provided with the OS, Android OS, and making it vulnerable to the attackers. So the dynamic analysis part should also ensure that the application is installed on a normal device, not an rooted device. So the other benefits could be analysis of application integrity implication. So it also provides insights into security of endpoints, API endpoints. So the tools which are used for dynamic analysis could be Suite, so which is used for intercepting and analyzing the network traffic. So there is another tool, Browser, which focuses on interacting with manipulating the Android components. So Android components are such as activities, services, broadcast receivers, and content providers. So these are Android components. So there could be certain frameworks which will help and see the runtime behavior of the application. And there are also few dynamic instrumentation tools which are used to hook the certain methods on the source code or the runtime application and try to see which can be exploited. So the tools could be FRIDA and objection. So now we will try to look into behavior analysis. And as part of behavior analysis, monitoring the application's behavior in various runtime environments to detect anomalies or malicious activities. So, it tries to monitor how an application interacts with system resources such as file system, network, memory, and CPU. So it monitors the permissions and access control mechanisms of the application during runtime execution. So there are certain authentication or authorization issues that one can find as part of behavioral issues, because there could be certain user roles like admin user role, analyst user role, developer user role. Because the developer user role, whatever the authorized resources which are used by developer will not be like will should not be given access for analysis. So these kind of behavioral aspects will be evaluated as part of behavioral analysis. So it helps to understand how the app reacts to the unexpected conditions. It also assesses how the app handles cryptographic operations such as encryption, decryption, and key management. So the focus areas could be the battery. So some of the apps which may be looking like it will be having minor functionalities, but in the background it could have trying to perform certain operations which could take the battery. It will consume the battery more. It will take the CPU amount of CPU process more, or else the memory, it may take more usage of memory. So these all aspects that we can try to evaluate as part of behavior analysis. So it detects the malicious activities like once the app is on your device, it could exfiltrate your data to its server or any hidden background processes which are running as part of the application. So it also tests the malware or spyware behavior in the real world conditions. So behavior analysis in mobile security are critical for understanding so what are the benefits that we one can get out of behavior analysis. So it tries to perform real-time operations on the app and identifying security, performance, and usability issues. Unencrypted network traffic, sensitive data such as user credentials, credit card information, or personally identifiable information. So it identifies instances where the app or its components improperly grant elevated privileges, such as system level access. So detecting issues like excessive CPU usage, memory leaks, or inefficient data processing that could degrade the app's performance. So these are all the aspects that we can evaluate as part of behavior analysis. The tools that one can use to perform this type of analysis are sandbox environments, because there could be the sandbox environments which are isolated environments on which the app will be installed. And it will be made to run for certain time limits. So and during the time limits, we can evaluate how the system resources are being used by the application. So there is another tool called Train Droid. So it tracks and analyzes third-party apps on Android devices, which collects, shares users' private data in real time. So there are Quark engine, which would help in automating the analysis process of suspicious Android applications. There is another tool called AppMon, which monitors the behavior of mobile apps and helps to identify memory leaks, crashes as such. So now we will go into advanced static analysis for Android application security testing. So as I told, security testing is the testing which will be done before executing the application. Here, so this type of testing will help us in analyzing the malwares to and see the behavior of the malware. So before we name any app as malware, so there are sophistication methods that we have to use and examine the software or the code in such a way like to understand its structure, behavior, or potential vulnerabilities at a deeper level. So the as part of advanced static analysis, so we will try to analyze the code's logic, how the developer used any codes are getting inserted into the logic. So like that. So any the data flows, the control flows, or the interactions with the external systems. So the key aspects that are covered as part of advanced static analysis. So it could be data flow analysis. So it sees how the data is being flown through the source code. Like once the users provides the input, then that input is processed and how the data is transitioning through the source code as such. So how the control flow analysis. So what are the certain conditions are met or not met. So taint analysis. So here there could be some tainted data that will be provided as input and how that getting transitioned during the process of the application. So there could be symbolic execution analysis of the program by simulating execution and with symbolic values instead of concrete inputs. So here these input values will help us to understand how the like the the code is executing, or the code is processing, the code is flow, the control flow is like observed as part of symbolic execution. So these are the key aspects of the advanced static analysis. So there are a few more, which could be abstract interpretation, which is used for mathematical models to approximate the behavior of the program. So there are certain dependency analysis, examines relationship between different components, libraries, or modules in the code. So there could be pattern matching and heuristics. So uses predefined rules or machine learning models to identify known vulnerabilities, anti-patterns, or malicious code. So here there could be some malicious code which is already reported earlier, and we can build certain machine learning models, and see such same similar coding patterns are there in the application or not, and with which we can say that this code is malicious, and we can classify that accordingly. So there could be cross-platform and multi-language support. So advanced static analysis tools uh, often support multi programming languages and platforms. So enabling analysis of complex or heterogeneous systems. So what are the advantages? So it is for my vulnerability detection. So the vulnerabilities could be buffer overflow, injection vulnerabilities, or insecure API usage. Compliance checking is another advantage. So malware analysis is also one advantage. Code quality improvement and reverse engineering. So these are all the advantages one could get out of advanced static analysis. So what could be the challenges? So the challenges could be false positives, the complexity in analyzing the source code, and in setting up the lab environment. So the performance, the code bases can be slow, and so we have to the code base will be very large, and the systems may not be supporting for analysis or using any tools as such. So there could be evasion techniques, like there could be obfuscation, that the code obfuscation is already present in the source code, which may have which may be cumbersome for the analyst to understand the code. So these are all the challenges, and the best practices could be use multiple tools to reduce. So we can use multiple tools for reducing the false positives. We can have regular update and signatures to detect new vulnerabilities. So there could be signature database of the apps, so which will help us to see that app is properly released by the developer, by the correct developer or not. So there could be we can integrate static analysis into CI/CD pipeline for continuous testing. So we can train developers to interpret and act on static analysis results. So now we will get into reverse engineering of Android APKs. So what is about reverse engineering? So reverse engineering involves analyzing the structure and behavior of an application to understand its components and functionalities. So given an APK which was released by the developer, so the analyst can or the attacker can reverse engineering using certain tools and get into the source code. So the main purpose by the security analyst could be, so if a given APK is there, so which is we are not sure whether the APK got released from the right developer or not. So then for the security analysis part, so one can take the purpose to detect the malwares if there are any in the source code, or any malicious code which is present in the source code, any vulnerability discovery that one can uh, get as part of the reverse engineering. So we can try to analyze the app functionality. We can also see whether app integrity is being intact, and by verifying, and code optimization techniques are followed, and refactoring procedure are properly implemented, and intellectual property protection are being taken care. So this is what the major outlook about forward engineering and reverse engineering. So for forward engineering, we will try to get the specifications or the requirements. Then we will try to design and implement implement or develop the source code, and also that will lead into the new system which is built. So, but coming to reverse engineering, this will be the vice versa process. So we have a system in place, and we will try to reverse engineering and convert that running application into into get the source code from that application and understand and transform that source code into the requirements. So this is what the uh, uh, pictorial notation or the diagrammatic representation of the reverse engineering by comparing it with forward engineering. So, what could be the motivation for reversing? So, we will try to see the interoperability, like the application of software to work on another platform. So, we will see whether the given application APK is there, but whether it is also being able to run on other device which is which may not which may not from the same OEM as such. So there could be the developer may have lost the documentation and the documentation to be required for that app to enhance it and add more functionalities to it. So there could be product analysis team that would need the reverse engineering. There could be security auditing teams as such. So the common techniques that are adopted for reverse engineering are decompilation, disassembly, string analysis, binary analysis, tampering. So these are the common techniques that one can follow to perform the reverse engineering. Uh, the tools are APK tool, Dex2Jar, JADX GUI, IDA Pro, and Ghidra. So these are the tools that are used for reverse engineering of the given APK. So, what are the steps that one can follow for performing the reverse engineering? So, once for reverse engineering, the analyst should obtain the APK. It could be from the app store from any other source. So, they have to recompile and disassemble the APK and using these tools, JADX or APK tool, and start analyzing into the source code and see for the hard-coded secrets, insecure implementations, or any points where the data is getting leaked. So now we will try to see, get into the tools, how these tools can be used. So there are tools are ADB tool, ADB, APK tool, and JADX. So APK tool and JADX are the basic tools that are used for reverse engineering, and these tools will be used from the ADB platform. So ADB is an Android device bridge, which is a command line tool for on the Linux machines, and we can run certain commands like ADB devices, ADB version, or ADB shell, which will provide the information of the devices, version of the ADB, and the information of the device which are connected to the PC. So once you extract the DB, so these are the commands that one can execute to extract the APK from the device for performing the reverse engineering. So like ADB shell PM list packages, which will list the packages list, and from that list, which is the APK that you want to you want to reverse engineering, and the APK will be identified by the package name, that's com.example.app, and how to pull it onto your PC. So this is what the command that can be used, ADB pull command. So there is another tool. The other tool could be JADX. JADX is a tool which is used for reverse engineering. So this tries to convert the APK into DEX file, and this is the GUI mode of the JADX will help you to look into the file structure of the APK and also the source code of the APK. So this is the interface of the JADX. So here there are a menu bar, toolbar, source code viewer, project view, status bar, code switch. So this is how the source code can be viewed as part of JADX. So so you can search to the keyword which you want to search in the source code from the navigation, like the menu items, and go to the particular source code line and analyze accordingly. So JADX uses is an decompilation tool of the APK. So it analyzes the source code. It also have the main activity Java or app config Java, etc., or depending on the app structure. So the file structure could be strings.xml, colors.xml, activity main XML. So these are the file structures that one can get out after the recompilation process. So JADEX analyzes it extracts the source code from the source code, the original Java code. This makes it much easier to read and understand and analyze. So it also examines the resources folder, Android manifest file, so which contains permissions, components, activities like the components as such, libraries or native code, the assets folder. So these all information one can find after reverse engineering the APK using JADEX tool. So this is a Java file which can be viewed. This is a sample Java file which can be viewed as part of JADEX. So the other tool could be APK tool, so which is also used for reverse engineering. But here one can build the APK. Like once you reverse engineering the source code and we can still modify the source code and build the APK from this tool and install that on the device. So this is another type of tool which is called disassembler. So these are the commands that are used by the APK tool for disassembling the APK. So APK is decompiled, like APK tool organizes the output into several key directories, like smali is one such directory, resources, Android manifest, assets, and library. Uh, so this is the sample smali file that one can understand there. Uh, So the analysis of the Smalley code could be the Smalley code is the low-level representation of the bytecode. So each Smalley file corresponds to a class file in the app. So Smalley code is widely used in reverse engineering modifications. Like as I told, we can modify the code at the Smalley level and repackage it and release it. So this could be one way of doing the things like that. So Smalley code can be modified to bypass certain security mechanisms. So this is a table which tries to compare between the Java keyword and Smalley keywords. So the declaration class will be in such a way, like here it will be class, here it will be dot class. So it extends will be the inheritance of the class, here the super. So these are the keywords that we can compare between the Java and the Smalley equivalent program constructs. So here the decompile code can be analyzed on the Android manifest file. If you take the Android manifest file, there could be permissions, services, and intent filters, which will be analyzed and check for the configurations. So we can also inspect resources like the layouts, drawables, or strings, which are available in the resources or resource directory. So these resources can be give more insights about any hard-coded data as such. So this is the comparison between JADEX and APK tool. So here the decompile output, and here we will get Smalley code as part of APK tool. So these are the aspects that are compared whether what we get from JADEX and what we get from APK tool. So now we will try to see how to protect the source code or the APK from any reverse engineering attempts. So we can check for the devices. So the APK should try to check. We have to ensure, like the developer has to ensure that the code is properly obfuscated and may withstand any reverse engineering attempt. So there could be the encryption methods that are strictly followed as part of sensitive data which is stored on the device. So there are certain secure communication protocols which are to be adopted or implemented in the source code. The secure coding practices are very important for the developer to implement, and which will avoid any certain leakages or any attempts of reverse engineering as such by the attacker. So the developer has to perform the integrity checks, the hashing techniques that will keep the integrity of the application. So we also have the runtime protection like rooted or jail rooted device. So the developer has to implement certain methods to detect the device whether it is rooted or not. So it will, there could be advanced security solutions like employing cryptographic algorithms, RAS solutions. So these are also a developer should look into these aspects for implementing the reverse, like we implementing to avoid any certain reverse engineering attempts. So the application should detect whether the application is run on emulator as such. So these are also to be taken care by the developer while developing the application. So these are all aspects that one can try to protect from reverse engineering. So these are all about the Android app security that developer has to follow. And lastly, like we will try to see what are all products that we are developing at C-DAC Hyderabad. So so we are having the product by name mCoverage 2. So which is freely available in the App Store, and any citizen can download it and use. This provides the device security like the security advisor, the hidden applications which could be there on your device. So there could be app statistics that can be provided by this app. So these are all the features that one can get from the this apps. So we also have Parikshan, which is an automated security analysis tool of Android applications. So we can, if anyone is interested, you can contact us through proper channel to discuss and further on the tool. So there is another tool which is mPraban. So which is for enterprises like the employees in an organization using organization applications on their devices. So this can be controlled by the admin of this tool. And to have this to know more details about these tools, you can come through proper channel and contact us, and we will provide you all the information which you need. And if it uh, satisfy, like it meets with your requirement, then we can take things further. Yeah, this is all about the app security, mobile app security. So any questions we can take now.
Thank you so much, sir, for giving us this presentation. Of course, you very well explained how we can actually take care of mobile application security. And there are certain questions which we have received from the viewers, and let me ask few of them because we do not have enough time left with us. So there is this question, the person is asking, it's about emerging trends and technologies. So the viewer is asking, how can these technologies help improve mobile security, and what are some potential challenges?
Yeah, here as I told in the presentation, so we have fragmentation of devices because there are, if you take Android platform, so we have so many OEMs that are manufacturing the devices. So, and each device may have different OS. So if you take Motorola, Moto company, so it has lot of models, and in each model there could be one version of OS. So these are the challenges that the security analysis may have difficulty in performing the analysis part.
Right. So there is another question, and the viewer is asking that how essential or important some of the features in mobile security are, like real-time scanning and threat detection. How these features are important, or there are some other features that are equally beneficial for the users when it comes to mobile app security.
Yes, we, yeah. If you take about real-time software, so it is something like uh, um, we develop. So there could some injection attacks could happen in real-time software. So the real-time software has to have certain security analysis to be performed before it gets released into the public domain. So and also there could be some machine learning models that which can be developed. So as I have shown you the mCovers 2 app, which having this threat analyzer. So here, once you, as part of this tool, so once you install any app on your device, so it looks for the threats that could get posed from by that app. So this can be this that can indicate so which are all threats that app could pose you during its usage. So these all aspects can be taken care in that way.
Okay. Sir, there is another question and the viewer is asking, what are some emerging mobile security threats and how can they be mitigated?
Uh, Yeah, the major threat could be the sensitive information which is stored on the device.
Hmm.
So, so we have to ensure that the encryption methods are the latest methods and very strong encryption methods which are implemented in the application, like AES Advanced Encryption System, which is 256. Uh, 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 which uses advanced encryption system. So these algorithms to be implemented by the developer, and the security analyst has to ensure that these are implemented. And another thing could be so the hashing techniques, like as I told, SHA 256. So this
Okay.
is basically used by the developer in the implementation of their source code. So this will try to help them withstand with any emerging threats that may try to attack the application.
Right, sir. There are possibilities of certain upcoming threats, but by following all the rules and guidelines and certain tips that you shared in the presentation, we can very well protect our mobile devices and various applications. Sir, now it's time for me to wind up the session because we do not have enough time left, but we do thank you for your time and contribution to this journey. Thank you so much.
Yeah, thank you, ma'am. Thank you for me. Thank a lot for giving the opportunity. It
Thank you.
was great.
Thank you for being a part of this, sir. So, viewers, here I am now winding up this session, which took place under the umbrella theme of our training program, Device and Network Security. Today on day 3, we talked about mobile and app security. Well, with this, I'm wrapping up the session over here, and I'm sure that you will visit the CIT website for more guidelines if you wish to attempt the assessment. Now, to all the students out there for grade 4 and 7, if you are looking for textbooks, you can purchase them now on Amazon, Flipkart and NCERT website. They are available there, and simultaneously you can take a quick look at the schedule, what's all coming ahead. Well, this is the list of programs, and you can watch all these programs on our YouTube handle, and in a short while from now you can watch our session Sahyog, where the topic is going to be digital social media detox for mental health of students. Of course, it's important to keep ourselves sane and to keep ourselves updated at the same time, but not stay hooked to social media. Well, with this, it's a wrap. This is me, Harpreet Kaur, taking leave of you. Please stay tuned for more educational content on our various platforms. Namaskar.